Okay. I think we can start then with whatever we want to do. So anybody has some urgent topics?
Not urgent, but it's getting to that time of the month where we merge things.
Yes. Yeah, we can start with that if you want.
I have no preference.
I mean, what kind of pull requests do we have that we need to merge in? Look.
Well, I suppose what is ready is your multi-line config option, right?
Yes, that is
ready.
ready.
I think Toby said something on that pull request.
Oh, you're right. Yeah. Adding some comment. Yeah, maybe I will do that later. That's actually a good idea.
And my other two pull requests, I think, are good to go.
Yeah. Which one do you want to have first?
Well, it needs to be 989 first, because I merged it into the boundary conditions one already.
Okay.
Because in the hybrid parallel tests, I put it to compile with single precision to keep that in under regression as well.
Yeah. Okay. I mean, the mixed position. Yeah, I think that's okay. You did all this AD stuff there.
Yeah, I did the data types and the AD. And that was it.
Okay, but in that pull request, you have not moved the files yet, right?
Which ones?
The AD files.
Oh, you want to move them? Move them where?
In a subdirectory.
I thought we would just be cleaning the, removing the inlines and that would be it.
I thought that we want to move like all the files into like some common subdirectory.
Yeah, we can do that too. It's just
so the AD structure, the data type structure, because they're all related. Well, not directly actually.
Well, they both include each other.
Yes, exactly. So they're kind of related, I would say. Yeah, I thought that. Yeah, I don't know.
I don't know. It's just a matter of where to put them.
Yeah, maybe there should be a common data type like directory. I think that's also where the AD structure fits actually. I mean, it's only AD structure left and data type structure, right?
Yeah.
Then we move them in a common directory or in a separate directory. But I think I would love to have like all files in like some directory at least.
Yeah. Well, right now they're in common.
Yeah.
It's the
okay, like a directory in common. Yeah, or do you think it makes no sense?
I don't know. I'm just looking at other things that we have that could make sense. should probably keep them together.
Yeah, that's also what I think. Because also in the data type structure, there are a lot of AD things actually. This is why I would maybe call it like data types or whatever. Or just types. I don't know.
Yeah, types make sense, I guess. Then we have some things in toolboxes that are also types.
What do you mean?
Well, we have some containers and.
Oh, this. I mean, with types, I just mean the basic like floating point type.
Well, should probably call it SU2 double then.
Maybe. Yeah, it is all related to that. So.
Yeah, everything it does, it's around the SU2 double.
Yeah. Okay. It's fine for me.
Whatever.
Maybe SU2 double type or something like that. Yeah, we can go for that.
Let me see in how many places that header is included. Maybe.
Which one? The data type structure?
That one, I don't think it's included in too many places, but the AD structure probably is AD structure.
I think that they're all indirectly included through, I don't know, API structure or something like that.
Yeah, they're not included explicitly in too many places. Yeah, the AD structure is only included in 2 places.
Yeah, might be.
And the data type, about 10. Oh. In some of them, there you don't actually need to include it. Probably depends how pedantic we want to be with the includes.
At some point, maybe we also have to clean that up, but that's not necessary right now, I think. I think there is a lot of room for improvement regarding the includes.
Yeah. Okay, so we'll call it what, SU2 types or just types and basic types? I don't know.
Yeah, maybe basic types is good.
Okay. Okay, I'll do that.
So you want to put it in that pull request? Or do you want to have a separate one?
Either way, it's fine.
Well, then put it in there, and then we merge it in next. I mean, this is a change that should not affect like a lot of people, so we can just sneak it in.
It's included in a few files, but yeah, it shouldn't be. I don't know. Git is funny sometimes. Sometimes you delete some spaces from one line, and on the top line you change the name of a function slightly or whatever, and it gives you a diff on on the two lines.
Oh yeah, I know.
Because on one line you change the space, and not even on the same line you change the name.
I mean, for the majority of cases, it works fine, but there are some corner cases, yes. Okay. Then we have decided that. That's good.
Yeah, slightly unilaterally or bilaterally.
I think that, I mean, if there's objection, please speak up.
Yeah, someone in the audience wants to speak now or
we
forever.
can also make like a vote, but I don't think it's necessary.
There's a lot of people in the call. Did you guys have your mics broken or something?
That means nobody has objection. This is good.
Well, but
that means we can continue deciding things.
I don't know.
Okay.
Or maybe they're afraid of you, Tim. I think they're afraid of you.
Yeah, I can understand that. I would be also afraid of myself. Okay. Yeah, so, well, actually, I can merge the multi-line thing in. Oh, no, I wanted to add the comment. Sorry. Yeah. You're right. Okay, then I will wait also with that one. Then 989. Yeah, okay, I mean, there are not that many left. I mean, these are just these two from your end and mine. That's it, I think.
Yeah, I'll move the files in the 975 one because it's the branch I currently have checked out.
Yes, you can also do that. Yeah.
If it's okay, we can just merge the other one now, and I'll move the files in the other branch.
You added all these performance charts later, right? Okay. The problem is that if you edit like the pull request, then I don't get a notification of that.
I added what? Sorry.
So you added some charts there, right? For performance in this mixed precision pull request.
Yeah, I edited the thing. Yeah.
Yeah, that's always the problem because then you don't get a notification that.
Well, I mean, that's a problem, but it's probably also a blessing for some people that
yeah,
don't want to get spammed all the time.
Hey guys, this is Tom. Sorry I'm late.
Hi Tom, no problem.
I was just going to say, I think that one you're talking about is ready to go. I already left you that review and you, I think, addressed everything, so I can approve the mixed precision.
Yeah, we were just talking about moving the data type structure and AD structure to their own little folder, which we will call basic types. That was the thing, right, Tim?
Yeah, exactly.
Sounds good. I've got a branch with the fluid model stuff mostly divided. I'm actually rewriting a little bit of it as I go, so it's taking a little bit longer. So I'll put that up in the next day or two.
But you don't, yeah, okay. Then we wait for the next release to merge that in, I guess.
Yeah, yeah. I think
makes sense.
Whenever we're ready, it's fine. Are you trying to do it? Maybe I missed that at the beginning. Are we trying to push out a release this week?
Yeah, but we don't have to do all the restructuring already. I mean, it's just a usual maintenance.
Oh yeah, let's just do it as we go. Yeah, that's fine.
I talked to Brian about grid adaptation structure, and he said he doesn't use any of that, so we can safely remove all of that. And also, we can probably remove SU2 mesh, because I don't think anything uses that anymore either.
Yeah, we've been talking about that for a while. The only thing we had been using it for within the last couple of years was periodic boundaries, but after rewriting all the periodic stuff, it's not used at all. So I think it's safe. Take it out.
Yeah. I'm always happy if we can throw out stuff. Well, stuff that is not used, sorry.
So are we doing that for this release?
Yeah, it's not necessary, I think.
Yeah, no, I'll need a little more time to get all those changes sorted.
Okay.
Okay.
So I had a separate question from who is working on the or who worked on all the Python wrapper stuff, because I am trying to get the geometry evaluation stuff through a Python wrapper, and I don't really know much about Swig, how to set up those make files. I'm just looking at what was done for C driver and like the Meson build files for that, and it's a little confusing. So is there someone I can ask?
So originally it was done by David from Liège, but he's not involved anymore. Then Ruben did some stuff with that, but he's also not involved that much anymore. So I think Mladen dealt with some of the Python wrapper stuff. Maybe he has
yes,
already some experience with that, so he might be the person you can talk to.
Yeah, sure. I can give you a brief introduction. Actually, for creating a simple wrapper classes, it's pretty simple to do. There are only a couple of files that have to be updated with the classes you want to wrap to Python.
Yeah, that would be super helpful. I'll message you separately on Slack to set
Yeah,
that
sure.
up. Thanks.
I'll be glad to help.
Perfect. So, what else regarding the pull requests?
Should probably try and squeeze in that fix that Tom found for the symmetry problem, right?
Yeah, that's if you could have that in for the next week, that would be awesome. But if you guys think that it still needs some more testing, then I'm also fine with that.
It's definitely a fix, right? So even if it's not perfect, it's just a couple of lines.
It's definitely better, yeah. But Toby, I don't know, you can maybe comment.
I just chatted with Rocco prior to this meeting, and he will do his test case until end of the week, I think he said. But yeah, if he actually recovers his old results, I'm super fine to merge that in. But otherwise, I think, yeah, it would be great to have that in as soon as possible.
Can we maybe open already a pull request to see whether the regression tests run and give no major differences?
Yeah, sure.
Yeah.
Because if they don't show any major differences, then we don't have to necessarily wait for Rocco's results.
Yeah, I can put it up. I'm guessing how many? We have a couple cases that are under regression tests for grid velocity, but I don't know if any Euler ones are. In fact, it'd be good to have the Cardano and Tongue
Is there an Euler case? Yeah, I'm also
rotor.
is there an Euler case with the pitching airfoil?
Actually, we have the rotating airfoil. We could put that in there. We might have a pitching airfoil too in Euler. I just forget. I'll go check. But it would be a good
otherwise
idea
we can
to add
use
one.
you mean the Cardano tongue rotor?
Well, that one's 3D and it's not huge, but it's a little bit big. There's a 2D NACA 012 case we could put in there in the same folder. That's just a steady rotating case. I'll check.
Yeah, just in case
there
is no such case. Otherwise, we don't have to add like a further one.
Well, I'll start it and we'll find out, because if there is, it'll change the regressions. So.
True. Yeah.
Yeah, I can do
that
right now.
But probably there is not actually. Otherwise, we wouldn't have that problem right now.
Well, Toby.
Yeah, so all Toby's fault. No, sorry.
I mean, yeah,
I was going to ask, because I think some of the regressions changed back then, right, Toby?
Yeah, I changed like a giant bunch of regression tests when I merged that or for that pull request. And that might have just slipped through because, yeah, sometimes it's, of course, not so easy to see that in a couple of 100 steps or so, and to judge whether that's faulty or not.
No, I think all the ones you changed, I think were correctly changed, because, I mean, I remember all the symmetry plane. There are a few Euler, Honora cases, stuff like that. I mean, I think all that stuff was correct. So.
Oh.
Yeah. Okay. I'll put it up. That's only like 3 lines.
Okay. That's good. Then we have that solved. I'm really happy about that.
Yeah, that'll be a good fix. Pedro, I had a question just to finish off the mixed precision pull request.
Shoot.
Did you, in the end, get any big performance improvement just in terms of time per iteration? I was kind of curious about that.
Yeah, I have well, depends what you call big. So the one my usual benchmark is about 20% faster.
Okay.
It's in the original text of the original post of the pull request.
Yeah, I was reading through that. It was maybe I should reread it. I wasn't sure if you meant that it was because of the plots. It looks like it's converging in. Oh, I see. That's time. That's seconds, not iterations. Yeah. Okay. Perfect.
So it converges in the same number of iterations to exactly the same residuals and so on, because we only converge the linear solvers to, I don't know, 1 to the -2 or not even. So they don't really need to be solved in double usually.
Yeah, no, it doesn't matter for the iterative part.
So only for things like mesh deformation and so on is where you could see some problems, which is the other plot that I have there. That if you try to go to converge things super accurately, it's going to take more iterations just because you have more error accumulating.
Yeah. And
nice.
What about the memory for the solver? Does it have some effect?
Yeah, it's good savings. I would say it's about 20% as well.
Okay,
you can basically get the ILU for the price of the LUSGS.
Okay, yeah. Yeah, very good.
I was looking into that because of a question on CFD Online, and the ILU preconditioner uses about 1.7 gigabytes per million cells, per million nodes. Sorry, if you have an hexaedral grid.
Yeah, I think a long time ago I ran some tests just to check memory, and I think overall we're something like 7 gigabytes per million nodes, like grid points.
Yeah, it will depend on the type of grid and options you choose and so on. But yeah,
that's
so the numbers I got were actually 8.5 gigabytes. If you have ILU and, well, not 8.5, 8.2 or something.
Yeah, maybe we can have like some people test what they think about this change. So for their cases, they see also that this has no influence on the number of iterations and the accuracy, which it should not, I guess, but who knows?
Yeah, I mean, I think as long as it's not the default, we should still just put it in. I mean, it's a good change. I know that
we should get it in nevertheless. Yeah, of course.
Yeah, I think OpenFOAM has this. A couple other solvers do this. I think it's a great idea.
Yep.
Yeah, CCM Plus is mixed precision by default. CFX is single precision by default. You need to enable double precision if you want it.
That one's a little weird for me because, I mean, a lot of turbulence models have trouble.
Exactly. Evaluating those residuals close to the walls and so on. Yeah, a bit tricky.
No, but
I mean,
in the linear solver, it's a win. So
yeah, they say they are single precision, but you never know if they still have some special measures in some places of the code.
The linear solver for the edge also uses then float, right? Yeah, I guess so.
Yeah, so this will apply to, if you compile, this will apply to AD as well.
Yeah.
Just not the forward mode.
Oh yeah, of course. Yeah, but that means that you should also see a big improvement there actually. Well, the same kind of improvement, maybe even better, I think.
Yeah, the adjoint tends to do a few more linear iterations, I think. So
yeah, exactly.
Yeah.
And that's actually most of the work. Well, also for the flow server, most of the work's in the linear solver, but for the adjoint, it's I think the percentage is even bigger.
Yeah.
But you have not tried that yet, right? Or did some comparison?
I have. This is my default compilation setting now.
Okay.
I haven't measured, but I only measured it for the primal. I haven't done a side-by-side comparison for.
But you noticed it already.
Yeah.
Yeah. No, it's a very good change actually. I like it. Okay. But you said that we can merge it in, right?
Yeah. Approve that one, and I'll move the files in the hybrid boundary conditions one. Because it's the branch I have checked out at the moment. So
yeah, I'll approve that one right now. Actually,
you can also click on merge if you want, or someone. can have the pleasure.
I'll leave it to you guys. Somebody else can have the fun. I usually just leave it and let whoever is working on it merge it, but that's just personal.
Because you don't want to have all the merge commits, right?
Yeah.
So if someone wants to boost their statistic, please go ahead.
It doesn't count.
It depends on where you look. I mean, there's this JIT short log, and you can explicitly disable there the merge commits, but if you don't, then it counts to your commits. But
I thought I saw sometime that it says excluding merge commits or something.
yeah, it depends on what statistic you look at, I think.
Do we get prizes for?
Just
we can certainly think about that.
Just a lot of pride.
For example, we just had issue 1000, and I mean we didn't give away
I thought about
prizes
that.
for
Who was that? You probably, right?
No, I missed
No, it was
Was it an issue?
It was a bug.
Oh,
yeah.
No.
Yeah, we wasted it on a bug. It should have been something.
Okay. Yeah, but it's good. Cool. Over 100,000. Very good. Although the majority are bugs, but okay. So is there something else regarding the pull request? I don't think so. Anyone wants to suggest some other topic? If not, then I can show you what I was working on. But let's see if
expression language. Yeah, I think that's a good idea.
Yes, I wanted to show what the status is on that one, because there are also some things we have to discuss. Because I changed so I changed the expression parser because I used cparse before and that was very slow. So I had to change that. But the problem is now with the expression TK, which is a very well-known library, the compilation takes slightly longer. Because this library is header only and contains 40,000 lines in one file. I don't know why they did that, but yeah, that's a major drawback, I would say. But nevertheless, it's used by a lot of companies and a lot of software projects. So I thought it might make sense to still have a look into that. But I try to hide it as much as possible so that we only have to compile it once and not in every compilation target. So I tried already my best. But let me just show you how that actually would work and what you can do with it. I think that's the important thing. What benefit that will give us. Share my screen. Okay, I hope that you can see my screen. Yeah, right.
It works.
Yeah.
Okay, so this is just the quick start case, and let me show you first how that works. So we have So what you can do with this expression for the moment is you can define custom output fields. So you can define arbitrary functions using all of the available fields that we have. Let me just look for the option here. Where was that? Okay. So the first feature that you have is that you can define like these expressions in an inline based thing. So ignore the average density for the moment. So what you can do is you can just define in this curly brackets here an arbitrary expression. So for example, what I did here is just dividing the drag by the lift. And you can do the same for the volume output here. So you can just take one field and for example, divide it here by the density to get the velocity. And you can, like I said, you can use all the available fields for that. You can also use functions like square root, exponential, whatever, almost everything that you have in C, in the basic C language for mathematical operations. It also works for this expression language here. So if we just run that, then, well, you can see it in the output that, we get exactly what we prescribed there. And in the flow file, we get the same here. So the name will always be the expression that you defined there. So that also works. So this is pretty much the only thing you can do with these inline expressions, but there is more that you can do. For example, you can define some surface integrals. But for that, you have to define a separate file at the moment. So it's hard-coded at the moment to functions.su2x, but we can change it to whatever we want to have. And here I defined, for example, a surface integral, which is the density times the area. And what the surface integral keyword does is it will, in the code, it will loop over all the surface markers and just sum like this expression here up. Same for the pressure here. So it's doing the same here. And then you have these fields available for every surface in the history, for the history expressions. So for screen output and history output. Here I did a further thing. I defined a history field, and then I used like this integral and divided by the area so that we have like an area averaged quantity. I mean, for that case, it makes not much sense, I guess, to have like an area average density over the airfoil, but it's just to illustrate how that would work. And then we can just go into the code, into the config file again, and we can just use it here as like a field. This, okay. And then if you just run it, then you see that we get the average density here. That, for example, that can replace like all of these output fields that we have currently hard-coded, like all these flow coefficients, like mass flow and average pressure and whatever on certain markers. I mean, this is pretty much how it looks at the moment. I mean, you can also define like volume integrals. Well, it's not enabled at the moment, unfortunately. But that file again here. So instead of surface integral, it's also possible to define volume integral. And then you can use the scalar value also in any history field expression or directly as an output. You can also use, sorry.
For the volume, can you specify a region of space, or does it just by default do the entire grid?
Yeah, I just wanted to say that. So you can use for loops, you can use if conditions, whatever inside of this definition here. So you can make you also have the coordinates available. So you could, for example, say that if chord x greater, I don't know, 0, and then you have this here. I just have to, I'm not quite sure how I did it. Usually it takes the last expression as the value. Maybe I have to add like a return statement or something like that. So I have not done it yet. But in theory, you can use if statements. Yes.
And we have, by default, you've exposed everything that we have at the grid nodes. So everything in C variable, as well as the geometry, or?
Well, you have everything that is defined in the output as a field.
I see. Okay.
Yeah, so it's not everything. You have to manually add it there. So with this, yeah, how you usually would add like an output field.
Okay.
And
so it's not direct access to the other containers. It's just, whatever you put in the output, it loops over that information to create the new stuff.
Exactly. It uses just everything exposed in the output. Yeah.
And these functions, how do they work in terms of the integral being evaluated? Like, will it call? So will it do density times area for each point on the marker? Okay.
So it loops over all the points in that marker, or in all of the markers.
Yeah.
So the surface integral is evaluated for all of the markers, right? So you have this density int here available for all markers in your domain. And it loops over all the markers and just sums it up, whatever is written here, whatever this function here returns.
Yeah, but when you write these functions, it's implicit that it will be called multiple times, and it's going to be the summation of density integral for each point.
Exactly.
So when we see coordinate x, it's going to be coordinate x of point 0, then point 1, 2, 3, so on.
Exactly. Yeah.
Okay.
Yeah. So this function is essentially called at every point on the surface. Same for the volume integral then. Yeah.
And a question towards the at notation to address a certain marker that is only available in this SU2x file, or is it also available later in the config file?
So this density int at airfoil, this this is a variable. So it can be also used as a normal field in the output, in the screen output option.
Okay.
There's also the possibility to do that. So you can have like it as a function. What it does, it will sum it up. So it will like give you the sum of the density int on the airfoil and the far field. But this one can only be used in expressions. But you can just define an inline expression in the screen output and then use it.
Yeah, nice. And when it comes to multi-zone, is there also some kind of like vector notation that you can address like one zone and then like, for example, like temperature in the one zone and pressure in the other zone and sum that up somehow, or is it not?
Yeah, I have to think about that. I have not yet thought about the multi-zone thing in detail.
The marker names need to be unique, right?
No, I think not right now.
Yes.
The marker names do not need to be unique?
Well, not right now, no. So if you just...
Well, they need to be unique for the interface.
Yeah, that might be.
I'm not so sure about that. I think I had a case where, I'm not sure if I have a case right now, but I had cases in the past where I just had interface for for both zones in the config.
I'm not sure how it is at the moment in the code actually, but probably it would make sense to make them unique actually.
I would cross my fingers very, very hard if I tried to use like repeating names.
Yeah, maybe we should like check that somewhere, I guess, to avoid that altogether, because that can lead to a lot of confusion, I think. Yeah, but I don't know how I would do it with or how I will do it with a multi-zone. I have to think about it. Probably some brackets or something like that, like it is already there. So you would probably do something like that, and here like the zone index. But yeah, I don't know how to do it with these functions here. Maybe it would be something then like that. I don't know. Although it would be a little confusing, maybe it would be better to do it like that.
I have a pedantic comment.
Yeah.
What you have there is surface integral. It's actually a surface sum.
Yeah, it's just a sum. You're right. Well, since the area is here.
Yeah, but usually from.
You can also do that.
And what would that give you?
Just the sum.
Yeah. So I'm just from.
Yeah, I also thought about that. Yes.
All the codes, most of the codes I used in the past in their expression language, they give you these options of area integral. They give you some area integral where the area is implicit to whatever you put in the expression. So the expression is implicitly multiplied by area and then summed.
Mm.
And also mass integral.
Yep. No, I think that makes sense. I was not quite sure what the best way would be for that. But you're right. Probably it makes sense to have like an integral and like a sum. Yeah.
But this is really good. I really like this. I think we're gonna delete 5,000 lines of code.
Yeah, that's might be possible. Yeah.
Yeah, what would the plan be to remove things afterwards? I mean, would we take out, for instance, all the different surface integral things that are inside of the flow solver?
Not all of them. So like all these average things, like average temperature, average pressure, they can be simply removed because we can just replace it by a very easy function here. But for example, something like drag is not possible, of course. That's way too complex. If that is what you refer to.
Yeah, I'm just wondering what kind of the upper limit could be.
Well, in theory, drag would also be possible, but that means we have to expose like a lot of things. For example, gradients and stuff like that, which might be useful anyway, but yeah.
Oh, yeah. I was actually wondering if, because I was thinking of adding those to the general output structure outputs as well, so that you get gradients, at least velocity gradients, because those are sometimes used for post-processing steps.
Well, we can expose the gradients anyway, yes. I think that makes sense.
Yeah, I was trying to. This was part of trying to get like a Reynolds stress tensor output from the RAND solver, and since especially for like boundary layer analyses and things like that, the velocity gradients are super helpful to have.
Yeah. Yeah.
Just a
yeah,
quick
sorry.
update on the boundary, or on the marker names between different zones. I just, for a case of mine, I used the same marker name for an interface in the fluid and the solid zone, and it runs, and I get the same residuals. So you can have exactly the same marker names in different zones. So maybe we have to restrict that, or yeah, we have to come up with some zone indicator number, like you already showed there.
And you have separate mesh files, right?
No, I actually have it unified in one file.
Damn.
I don't know what the best solution would be, whether we should keep it like that or not.
Well, if it works, I guess. But
yeah, I don't know. I mean, that can be discussed, of course. Still have to see how I do it with the multi-zone anyway. And the other thing that you can do with that approach is you can not only use it for the output, right? I mean, this is what I did so far, but you can also use it in theory to prescribe like initial solutions or boundary conditions or whatever. So it should be also quite useful for that.
Tim, how do you couple these custom expressions with CodiPack? Is it possible to do?
Yeah, it's already differentiated, the library, or this header only file.
Okay.
Yes, that works.
Cool then.
I have not validated it yet, but it compiles and it gives like a result.
But do you have to perform some manual coupling? I don't know how this code is. Is this code then translated to C++, or how this works?
It's not well. It's kind of translated to C++, but using like a template structure. I mean, it's very similar to what CodiPack also does. Right? It's just not done at compile time, but it's compiled at runtime.
Okay.
Yeah, like it builds also like a syntax tree and stuff like that, or like a tree structure of these expressions and stuff like that. It's the code is very complicated. And yeah, like I said, it like takes a lot of time to compile that header. It's it's not incredibly long, but it's like
you said 40,000 or 4,000, huh?
The header has 40,000 lines.
Oh my god.
And that's like that's like too much, I would say, for one header. But I don't know. But anyway, that's also a thing we have to discuss, actually. So right now, I just put the header into the source code the same way we have the tagplot.io stuff. So in an archive, essentially, because I don't want to clutter the JIT with one file with 40,000 lines. So this is why I just edit it as a binary file, and then it is extracted when you call the the build file. I don't know if anyone has like other thoughts on that.
And so you only need to, when do you need to recompile this this library, let's say?
Only if you change something in one source file in SU2. In this specific, but there's only one file essentially that includes that file.
Okay, so that's where you define what surface integral does, for example.
Yeah, exactly. Well, no,
Can you show us
actually,
that?
that surface, what the surface integral does, this is just passed as a string to the output module that deals with it.
Okay.
So even in that case, you don't have to recompile the code.
Maybe you can show us that as well.
I
So
can.
for example, if we want to define our own, something that is not a surface integral.
Okay, so you can see the code, right?
Yeah.
Okay, so I don't know how to make it a little bit bigger on the left side. Sorry for that. So there's a toolbox, our new toolbox folder. It's called parser. And in that, oh, wait a second. Let me go to the include parser. There's an expression parser HPP. So the code is not yet commented because I just finished it like yesterday. So yeah, this is just the interface essentially that you can use in the code. So it's very simple. You just can say here you want to add some variables that can be used in an expression. You can add like some string variables that can be used in an expression. Then you can add the expression itself. And you can just evaluate all expressions that are added. And that's the interface, the only interface or interface functions that you need right now. I use here like this pimple approach to hide the implementation. So that means the only place where this expression library is included is in the source file of that interface implementation. So that means that you only have to recompile that if you change something in that source file here. Yeah, because this library only deals with expressions, but not with functions. So it only deals essentially with this part here. The rest, this keyword and the history field keyword and the name of this function here, this is just passed by a separate code here. So this is just something I wrote like in, I don't know how many minutes. Yeah. So this simple parser for that function. And it just parses the keyword there. So this history field surface integral keyword. And then you can, like in this output module, in the user function module, you can just say, okay, pass like all the functions from file and give me only the expressions that have this keyword here. Yeah, and then this code just deals with whatever it gets here. Yeah, so that means here it is essentially determined what a history field is and what it does with it. I mean, this is just the first implementation, yeah. So it's not like it's not. I've not decided on everything, but I think that structure makes it, yeah, makes it relatively easy to add new things.
So then, what kind of how do you use that? How do you use the interface? You need to add you add the input. You add the fields of the output as variables. So.
Yeah, exactly. So this is essentially how it looks like usually. You add some variables here. So the history scope is like this option, this structure that you saw before. It's like here this expression parser.
Yeah.
And then you just add like all the variables that you want to use in like these expressions, and they are passed here as a reference. Yeah, so this is very important. So that means you can only, so these objects are not easily, they cannot be used in a deep copy. Yeah, that's like something you should be aware of. Then, here this is just some custom function that's not important at the moment. So you can hard code some functions that can be used in expressions. You can add some string variables, like I said before. And then you just say here, add expression. And this is just the string that represents an expression. So this is just, in that case, this part here.
Okay.
And then later, if you want to evaluate, you just call on the scope here. The scope is just the history scope here. And you could just call eval expressions, and then it evaluates all the expressions that you added previously to that object.
And because you gave it references,
yeah, exactly,
it's going to automatically write into where you want the value to be.
Exactly.
Right?
Yeah.
Okay.
Yeah.
Okay.
Yeah.
That's the kind of stuff we gotta be careful in documenting, I guess.
Yeah. So this is why it makes no sense to copy like the history scope objects.
Yeah.
Right, because they all contain references to certain stuff, and so here I already deleted like all the like assignment and copy constructor, and it's a unique pointer here in that case. So probably have to restrict it to this.
Yeah. So is there one history scope per output, or there's one for everything?
So in this function, in this class, there are two: one for the volume fields and one for the history fields.
Yeah, and each output you create. So in a multi-zone case, you will create multiple outputs, right?
In the multi-zone case, we would have like several of these user function modules for each zone.
Okay.
And then we have like a global one that has access to all the sub zones.
Okay.
Yeah.
Very cool.
And you can see that the code is not much, right? It's just this is the only code that deals with the history output user functions, or the output user functions.
Yeah.
Probably I will add an option to disable the user functions or the expression language altogether. Let's see. I have to think about that. Yeah, but that's all. I mean, this is just this code here, and the function parser and the expression parser, and that's it.
Okay. So then the surface integral is something that you implement on the output side?
Exactly. Yeah. It's not done here in this user function module because it is also used for hard-coded fields. So
Yeah.
there's a general method that just integrates whatever. So for example, I have these different modules here. There's, for example, the aerodynamics module. The aerodynamics module defines a volume field, for example, moment x, and this is a surface integrate type here. So all fields that are added with this type, they will be integrated and will be available in the history scope as a scalar for every marker.
Right. So when you define when you define one of those functions with surface integral type, what the code does, it will associate it will create the history field or whatever in this field type. Is that it, more or less?
You mean in this function here?
Well, not
So
that one, because that one is for volume fields. But if you define a surface integral, like the ones you had in the SU2X file.
This is exactly what this does here. So this one, so okay, let's see. So this field is set here, right, in this routine.
Yeah.
And that means then, since this routine here loops over all the points on all surfaces, it will just sum that up here, if it is like marked as a surface integrate here.
Okay.
Yeah, so this is, yeah, exactly. That's and then when you define like a surface integral in that function file, then it's treated the same way as this variable here, essentially.
Okay. So it's still going to be referenced by name, and because the field type is surface integrate, that's all there is to it, in a way.
Exactly. Yeah.
Okay. Cool.
And then you see that the lift and the drag are defined separately here as coefficients.
Yeah.
And they just can use like this integrated quantities here. So you see that we get here the force x from the history fields.
Mm-hmm.
And this is defined here as a surface integrate. But it is also available then in the history as an integrated quantity, or a summed up quantity in that case. If that makes sense.
Yeah.
Yeah. There was something very interesting that I noticed. So you know about this small string optimization, right? If like a string
they
is
have like a static buffer
characters.
inside.
Yeah, exactly. And that essentially gave like not a huge performance degradation, but it was quite severe actually. If you have these volume fields here and these names are larger than 15 characters.
Yeah.
Or not here, okay, but here, like when you loop over all the points, right?
Yeah.
Because then it creates like even though I have the caching in the background, it still allocates dynamically this string here.
Mm-hmm.
So I restricted them to be smaller than 15 characters. So there's an error now if the name is longer than 15 characters.
But you gotta be careful. I think that 15 is implementation dependent.
But that's the minimum.
Is it?
So GCC has this is actually GCC.
Yeah.
GCC, the smallest is 15. For Sealing, it's a little bit higher, and for the Microsoft compiler.
Okay. But yeah, it's compiler dependent, I guess.
Yeah, but I looked it up that it is that's the minimum. I don't know whether there is a method to get it as a constant or something like that in the code, but it's not available, I think.
And so the overhead is when you do what? When you set the value, or when you get the value for each point?
When you do this here, when you do set value, and then this one is larger than 15 characters,
Yeah.
then it dynamically allocates a string here.
So when you do can you use a string view?
Yeah, but it's not available in C++11.
Ah. Yes, fantastic. Okay.
That's the problem.
Yeah.
Yeah. So that was actually, I mean, because the cost for dynamic allocation is quite high.
Yeah, if you do it a lot, it adds up. Yeah.
Yeah. So now, but it's okay. The restriction is okay, I think, to have them smaller than 15 characters. I mean, you see that this one here is 15 characters. It shows 16, but just because of the null termination.
Mm-hmm.
So this one is the limit.
Yeah. But if you have one of those expressions, they're all going to be more than 15 characters, no?
Yes. So to be honest, I did like, so if you go here to the set value, I essentially made a distinction between an R value reference and just a normal reference.
Mm-hmm.
Because I thought, okay, if you add a field using a string literal or like an R value, then it's very likely that you also access it by an R value, right? Or a string literal.
Yeah.
And for the expressions, it's using this one here. And for like these ones here, the fields where you have a string literal, it uses this one here with a reference, and it throws an arrow here. But it's very interesting. I mean, you learn a lot when you do these kind of things.
What if you template this?
I also checked.
Can't you get like a perfect forwarding or whatever it's called?
Yeah, I also thought about that.
If you make it universal, universal reference.
I think, yeah, it probably should work, yes. But yeah, but it doesn't solve the problem. I mean, I still want to restrict the size. That's the main thing. It's not the forwarding itself here. Because all these functions are inlined. So doesn't matter anyway. It's just that here, before you call the function, that a string is created. That's the only problem.
But it's created because it needs to be converted to you have a constant string reference, so it needs to be converted to string.
You mean, yeah, but I don't know what it does. If you think that if this is a char pointer,
yeah,
that it is yeah, but it also then it has to allocate something, right? Or it's a constant then.
But if it's a constant, then it's just on the stack. Because compilers are funny with memory allocation, because they don't. If something requires memory, at least GCC, I've noticed this. If something requires, for example, if you have a function that doesn't return anything, right? It will optimize it to just be an empty function. If you do a bunch of calculations and you don't return anything, it will optimize it to be an empty function. But if you put new and delete in there, if you start allocating things on the heap, it will not optimize those away. So it can be
some side effects.
Yeah, because it's something, I think it's to do with because it's something that can throw an exception or something like that, it doesn't optimize away memory allocation, even if it's not. So I don't know. I don't mind the size
I can try it with the
limitation.
forwarding. I mean, I just have to, also do that with this function then here. Maybe it's possible to have something like that. That was just the easiest solution that I saw.
Yeah.
Yeah. Well, I mean, so you see that there are also like a lot of other changes regarding the output. So everything is essentially now in modules, and it uses the same structure that I briefly highlighted like a couple of weeks ago, but only in the output and not anywhere else in the code. Yeah.
So right now what you have is
that
instead of having multiple, you still have multiple different outputs, right? One output per solver, one output class.
Oh yes, yeah. So how it would look like for the flow output, for example, at the moment, I might change that, is that we have here also a separate module for the flow, compressible flow.
Yeah.
But since everything else is in a module, it only needs these outputs here. And everything else is reusable for other output classes using these modules here.
So you would specify the different fields you want by chaining these modules instead of repeating some things in the different output classes. Is that it?
Exactly. So you would do it essentially like that. Here, these are all the modules for the compressible flow output.
Okay. So then you don't have to do do you still have to manually add the outputs, or
what do you mean with manually adding the outputs?
So right now we do this output. You need to do the set history value and so on. When you first give it the name, not when you give it the value, but when you give it the names like add history output and add volume output and so on.
Yeah, but this is done in all of the modules here.
Okay.
So they define their own things, like I showed here, the aerodynamics module or the common module. Yeah, so that should remove like a lot of repeating code.
Cool.
And the only thing you have to do is essentially, if you write your own output, is to really add that in this modules, in this modules thing there. So you don't need a new or something like that. You just add it here and then it's there. Should make it rather simple. The only drawback is that the order of the modules like matters. But there's nothing I can do about that. For example, the user function module has to be the last so that you can use all the fields that are defined for. But there's no way around that, I think. Yeah.
Okay. So then each output class is literally just setting up a list of modules and that's it.
Yeah, exactly. Exactly. I have not removed the old code. This is why like this old thing is still
Okay.
there, but that is not used in that branch anymore here. So
Okay, because this was confusing me a bit.
yeah, no, this can be removed here. I have not removed like a lot of code yet. Yes. Of course, there are still some surface data here that is solver dependent. For example, the heat flux here, the computation is different from the compressible, from the incompressible, and from the heat solver. So I had to put it like here. Yeah, this is also something interesting here. I mean, I played around with passing the data to these routines here. I have not found a solution that's perfect yet. So right now I just use a tuple. It's because I don't want to pass like 13 arguments to the function here. So I don't know. There are like thousands of ways how one can do it.
Yeah.
So
Because the module doesn't get the solvers anymore, or?
yeah, they get the solvers, but in the solver data object here, which is a tuple. You see it here, because I don't want to like pass all of the pointers plus the iteration plus the current point that we are at. So in total, that would give like, I don't know how many arguments, like 2 here, 3 here, and yeah, it would be already 8 here.
Yeah.
So I thought it is too much, and it's also not maintainable, I think. So I thought, okay, I just make a tuple here and I pass the tuple, and then they just get the information that they need. Of course, that requires to remember at what position the arguments are, but of course you get a compile error if you use something here and the geometry doesn't have like a vertex, then of course you know that it's the wrong index.
Would it make sense to put it in a struct or something, so that you can call it by some name, or?
Yeah, but I thought, okay, if you want to add something, then it's also complicated, and I don't know. I had it like that before actually, but I changed it because I liked that approach better. I don't know. I don't know what the best way would be, actually.
Well, what people say usually is that text is better than numbers to identify things.
Yeah, yeah. Yeah, I have to think about it. I don't know. Yeah, the nice thing is that, okay, you can also do it with the structure. I mean, I had it before, but if you, no, sorry, module manager, if you call it, then you can call it with this curly braces, right? That's quite convenient, actually. So this is how it is called. Well, oh no, it has to be a make tuple here. Okay.
Yeah, but the struct can have a constructor, and you construct it in place, or?
Yeah. Now, in theory, it also works. It would work here if you do. Oops. If you do it like here with these braces.
Yeah.
But since the for each is a templated function, it has some problems in finding the correct function somehow. It's not able to instantiate it. I don't know.
Yeah, because that's going to be initializer list of something probably.
Yeah, I have no idea. But so I had to make tuple here, but let's see. But if you have a better idea for passing that, let me know.
I mean, it's just it's just a comment that Tom makes sometimes as well. We should avoid the magic numbers, and yeah.
Yeah, I thought that you get a compile time error, so I thought it is okay.
No. I mean, it can still be a tuple, but when you do get 0 or get 1, I don't know.
Yeah, I mean,
Maybe
nobody has any clue what that is.
Minimum for that, but yeah, I don't know.
Yeah, and did you say that a struct worked, but you just didn't prefer it?
A struct definitely also works, yes. I had that before, actually. I don't know what the problem... I mean, there was not really a problem. It's just that I was too lazy to add, like, all these members to the struct whenever I changed something. And it was much easier to just put it in a tuple. But I don't know.
Yeah, I think personally I'd probably go for a struct just because it's more clear. But I mean, you go with what you need to, and then you're going to put this up for review anyway. We'll say the same thing on your review.
Yeah. I mean, I don't have a clear preference. It's just complicated to pass like all this information somehow.
I think this has been the review already. You can attach the video to.
Yeah, no, it's good to have some feedback and to know what other people think. Actually, it's because I was not sure myself what the best way would be, because you always have like thousands of ways of doing something.
Yeah, I think just having the names associated with the variables inside of a struct is valuable, just for being clear. That's all.
Yeah. Maybe it's more obvious this way. Yes. Okay.
Tim, I have a question regarding this parsing library. Since the header is such a large file, can you treat it as an external library to Mason build system, such that it is downloaded like CodiPack or any other library that is used by SU2? Just an idea.
Can be done, yes, but we cannot use the original one because I made some modifications to be able to use the Cody type.
Okay, I see.
We can definitely put it somewhere as a separate repository or something like that. That would be possible, yes.
Don't you have to release it then if you make changes? What are the licensing terms?
The license is MIT, so it's very permissive.
Okay, so you can change it and keep it, and change it and distribute it, and okay.
Exactly. Yeah. Maybe this is a good idea to put it on in some extra repository. Yeah, maybe that makes more sense. Yeah, good point actually.
I guess you just expose the link to your fork on your GitHub profile, and then or something like that.
I will put it in the SU2 repository. I think I will edit. Maybe other people want to also use it with CodiPack. I don't know.
Mm-hmm.
So maybe it makes sense to have it as like as a general library. Okay. Yeah, I mean these are the most important changes, I would say. Unfortunately, it's already like a rather big pull request. But it's only affecting the output, so Yeah, so I mean, you saw also that the aerodynamic stuff is also in the output now. But the problem is that some routines still are in the solver and they need the drag, for example. That's still a problem. Giant has already left, right? Because I wanted to ask him something. Okay, you already left. Yeah. Okay, but I can deal with that somehow. Other than that, I would say that's it. Unless there are no further questions.
Not?
Doesn't look like it, right? Okay, then.
Thanks a lot for that overview.
Yeah, no problem. No problem. It's definitely fun to work on that. Like I said, I learned a lot.
Yeah, I get the idea that you're choosing projects to exercise C++ skills.
Yeah, definitely. I mean, you see that this whole modules thing there. There's no performance reason why I made it like using templates. You can also do that with, I don't know, virtual functions. But okay.
Yeah, but it's
But it's also easier because you don't have to add like a new blah 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 somewhere and stuff like that. It makes it very easy to just add a module, to just disable a module and stuff like that. I think it's very simple that way. Okay, I think we can then stop it here.
Sounds good.
Okay, then we see each other next week, I would say.
Yep.
If you don't mind, I have a couple of questions.
Of course.
Okay, so first of all, well, hello everybody. I would like to ask, is the multi-grid strategy only used for the mean flow equations, or also for the turbulence equations? Well,
Mean flow.
I've been checking the code, and I think it's only used for the mean flow.
Mean flow, yes.
And why it's not used for the turbulent? Because instability reasons, maybe?
I don't know. Ask Tom.
Yeah, that's just a legacy thing. So I think it's very common to not include it, but there's no great reason not to. In fact, in a branch somewhere along the line with the scalars, I activated multigrid for the scalars, so we could try it. I don't think if you're running first order for the turbulence models, I don't know how much you'll really gain, but could be interesting to try. The other problem is just a more general issue of multi-grid with highly stretched grids. So once the Reynolds number gets really high, you've probably noticed our multi-grid loses effectiveness. It can anyway. It's very much dependent on the grid. And so often with high Reynolds number RANS cases, I turn off multi-grid anyway and just go for a high CFL. But all that being said, I think you could go into the integration routines and switch from single grid to multi-grid, and I think it should work. There are probably a couple things you have to track down, but you could.
Okay. The second question is, the aerodynamic coefficients such as lift and drag are computed before updating the turbulence variables. So For example, the shear stress is only computed with laminar viscosity and not with laminar plus turbulent
Yeah,
viscosity.
that's the y plus
Yeah.
equal to 1 approximation or assumption.
Mm.
Yeah, and at the wall, most turbulence models are the variables are equal to 0, or at least the eddy viscosity is equal to 0 at the wall. So you don't need to include it.
Okay.
Yeah.
Thank you very much.
Yeah, of course.
But if we want wall functions, it shouldn't be like that. Yeah. Is that what you are going after, Guillermo?
I'm just checking because I need to modify the turbulence model, so I want to make sure about each point.
Okay.
Yeah, I don't know if you guys talked about the wall functions before I got on the call, but I am under the impression that it's never really been V and V, let's say. So I'm not sure what the status is. I think I've heard that maybe Eduardo was using it a little bit. I don't know if he's on the call, but I really don't know. I haven't been using the wall functions.
I think there were a lot of attempts to like do that, to integrate it somehow in a proper manner, but I don't know. None of these approaches worked out. I don't know. I don't know why.
I think it just needs a consistent, push to get it finished and well tested. And I just don't think anybody's had the time. It's not been a priority for anybody's project, unfortunately.
Yeah, that might be a reason. Okay. Then no further questions. Well, then I would say until next week.
Sounds good. All right. Thanks, everyone.
Okay. Bye-bye.
See you next week.
Bye bye.
Later.
Bye.